Hello my friends, congratulations again for completing part 1 data preprocessing. You are now ready to build machine learning models, and the first models that we're going to build together are regression models. So welcome to part 2 on regression. This is the branch of machine learning that aims to predict some continuous real numbers, like for example a salary or a temperature or any kind of continuous numerical value. And together we will build the best models to make these predictions. And so now, first of all, let's make sure we're all on the same page. This is the whole machine learning A to Z folder containing all the codes in Python and R and the datasets. I gave you the link of this folder right before this tutorial, in the article, so make sure to connect to this folder and also make sure to download the whole folder in order to get the datasets, because we will have indeed to import them whenever we build a machine learning model. All right? And so now, since we're all on the same page, let's start our new journey within regression. Part 2, regression, there we go. There are several sections inside, each section corresponding to a different regression model. We're going to start with simple linear regression, which is the simplest machine learning model you could ever build. And so it's good that we start with this, because indeed with this one we will only have one independent variable, one feature, and of course one continuous real value to predict. Then we will move on to multiple linear regression, which is based on the same equation than simple linear regression, only this time we will have several features instead of one. Then we will move on to polynomial regression, which will allow us to tackle some nonlinear datasets, datasets with nonlinear correlations, as opposed to the two previous models, simple linear regression and multiple linear regression, which can provide some amazing and accurate predictions for linear datasets, datasets with linear correlations. Then, after polynomial regression, we will move on to support vector regression, which is another kind of nonlinear model that can make some accurate predictions for nonlinear datasets with nonlinear correlations. And then finally, we will move on to decision tree regression and random forest regression, which can provide an alternative to predict an outcome for nonlinear datasets. So you'll have many options, After this part 2, you will have basically a toolkit of several regression models. And so whenever you end up with a new dataset where you have to predict a real continuous outcome, well, you can just try all of them and select in the end the one that has the best accuracy. And thanks to the code templates that will result from each of these sections, you will get very clear code templates that you can adapt to your own datasets, so that you can try these models on your own datasets in a flashlight quickly and efficiently, so that you can select the best one, giving you the best accuracy. And so now in this first section in regression, we're going to start with simple linear regression, of course. So there we go. Make sure to go inside this folder. We're going to start with Python, so let's go inside this Python folder, and you will find inside two files. First, the dataset salary-data.csv, and of course our Python implementation, which has the IPython notebook format, which I remind you can run on either Google Colab or Jupyter Notebook. And of course we're going to implement this model together on Google Colab. But first, let me explain the dataset and the problem that we're going to solve with simple linear regression. And to do this, I'm going to open our dataset here and explain what this is about. All right, so first, I want to reassure you that indeed, this is a very simple dataset, with only 30 observations. And of course, in real life, the datasets are more complex. But I want to start working on a simple dataset so that we can really focus on how to build the model itself, because if we had a complex dataset, we would lose a bit our focus on the model, and I really want us to focus on the model. So let me describe the dataset. It is a dataset containing, as you can see, 30 observations and 2 columns, with of course one feature. This is the feature years of experience, and the dependent variable which we want to predict, which is the salary. So let's say that this dataset belongs to a company that gathered data of some of their employees, collecting for each of them their years of experience and their salary. So you see, each row of the dataset here corresponds to different employees, corresponds to one employee of the company. And for each employee of this company, we have indeed the number of years of experience in the company and their salary, okay? And so the goal, very simply, is to build a simple linear regression model that will be trained to understand the correlations between the number of years of experience and the salary, so that it can predict for a new employee, having a new number of years of experience, well, the corresponding salary or the salary that this person should get. So you see, that's a very easy problem, but at least you'll know how to build a simple linear regression model and perfectly master it in all the detail. And then I want to say something very important. Remember that we're going to build each time some code templates which you can adapt to your own dataset, so that when you want to use the code template on your own dataset, you will only have one thing to change, which will be the name of your data. I will always make sure to make the code templates as much generic as we can, so that you only have one or two things to change when you want to deploy them on your datasets. All right? So, great, that's for the dataset. And now we're going to move on to the implementation, simple linear regression IPython notebook, which we're going to open with Google Collaboratory. If you don't like Collaboratory, that's totally fine. You can open it with Jupyter Notebook. And you also have the Python files in the folder that was also given to you in the previous tutorial, if you want to run it, for example, on Anaconda Spider or even the classic Python terminal. Okay? All right, so that's simple linear regression. Let's see how this implementation is structured. First, we're going to import the libraries. You recognize the first steps of the data preprocessing phase, which we covered in part 1. Second, we're going to import the dataset. Then third, we're going to split that dataset into the training set and test set. Then we're going to train the simple linear regression model on the training set. Then we're going to predict the test set results. Then we're going to visualize the training set results and visualize the test set results. But I don't want to show you this too much right now because I want to keep the surprise for the end. And so, what we're going to do now, because remember this is given in read-only mode, so you cannot code or do any modifications inside. But remember, I want this course to be as much practical as possible. I want you to really learn by doing, and therefore what we're going to do now is implement this whole simple linear regression model from scratch together. And to do so, we are going to create a copy of this file by clicking here on Save a Copy in Drive. This will create a new copy on your drive in which you will be able to do some modifications or implement the new model. All right, great. Now we just have to do one thing. It is to remove all the code cells because we're going to re-implement it from scratch step by step. So let's do this. We just need to click this trash button here on only the code cells. Make sure to keep the text in order to highlight, the structure of this implementation. So there we go. Let's just delete everything here. And one last, perfect. So now we have the whole structure of the implementation. You can clearly see the different steps that we're going to implement together. I will ask you to implement some of them on your own. And of course, then we will implement the solution together. But that's because I really want you to learn by doing. I really want you to take action and try to implement some parts of the models on your own. All right, perfect. So now I want you to think, what is going to be our first step here? Based on, what we covered in part 1. Well, our first step is obviously the data preprocessing phase, in which we have to import the dataset and maybe use some tools in order to pre-process it the right way so that our future simple linear regression model can be ready to be trained on this dataset. All right, and now I'm excited because I'm going to show you the efficiency of the data preprocessing template and how easy and fast it will be for us to pre-process our dataset here. So what we're going to do now is we're going to go to that previous folder, the data preprocessing folder, which was in part 1 data preprocessing, accessing the Python section. And there we go. Now we're going to open that template. Perfect. And you're going to see we're simply going to do some copy paste. And you'll see that we will only have one thing to change, and then the data preprocessing phase will be ready and done. It will be done for us to move on with the next step, which will be, of course, to train the simple linear regression model on the training set. All right, so now I'm going to show you what I've just said. I'm simply going to do some copy paste here. There we go. To import first the libraries and then adding them in a new code cell. Then to import the dataset, I'm simply going to copy paste this second code cell, and you'll see that I will have almost nothing to change. So creating a new code cell here, pasting it, and finally, let's do that final sub-step of the data preprocessing phase to split the dataset into the training set and the test set to, in order, I remind, have the separate entities where we're going to train separately the model and then evaluate it. So there we go, let's paste it. And now, as I've told you, we only have one little thing to change, which is of course the name of the dataset. And I remind, the name of the dataset is, we're going to go back to our regression folder here, very quickly, part 2 regression, simple linear regression, Python, and there we go, here we are. And as you can see, this is salary_data. So the only thing I have to change here is the name of the dataset, and then voila, everything is ready, the data preprocessing phase is ready, because indeed this takes automatically the features because it selects all the columns except the last one, and this selects automatically the dependent variable vector because it selects the last column. So here of course we have only one feature, therefore one column for the features and one column for the dependent variable, but you'll see for example that for multiple linear regression it will be exactly the same. We will have absolutely nothing to change here, okay? So now let me show you the beauty of the result. Don't forget, of course, to upload the dataset before, running these cells here. So to upload the dataset, you indeed need to click this folder here. Then it's going to connect to a runtime to enable file browsing, after which you'll be able to upload your dataset. There we go. So you click this upload button here, then you go to, this whole machine learning A to Z folder, which was provided to you in just the previous tutorial, which you had to download if not already. So indeed, we're going to go inside this folder, then we're going to go to part 2 regression, then simple linear regression, then Python, and there we go. We select our dataset, salary data, we open it, and now it is indeed in Google Colab. So perfect. And now we're simply going to execute each of these cells, first importing the libraries, then importing the dataset. Perfect, and now splitting the dataset into the training set and test set. And done. Now the data preprocessing phase is over and we can move on to the next step, training the simple linear regression model on the training set. So we're going to train our simple linear regression model to understand the correlations between numbers of years of experience of these employees in the companies and their respective salary. So it will understand and calculate all the correlations, after which we will be able to predict some new observations on which the model wasn't trained. So I can't wait to start this new step in the next tutorial, and until then, enjoy machine learning.